Is the first part of Chapter 6, Section 6, which is where we're solving logarithmic equations. First thing to recognize is, first of all, it's an equation, so there is an equal sign. Also recognize that there's either log or natural log written in the equation. So what happens is we're going to use what we learned in 6.5. Because we have a plus sign here, and they're both of the same base, that means that x plus 6 and x plus 2 are multiplying. So we write it as one logarithm. Log 5, x plus 6 times x plus 2. We don't mess with a 1. We then multiply this binomial times a binomial out. We get x squared plus 8x plus 12 equals 1. Now, whenever we're in a logarithmic equation, what we do is we push everything up on both sides of the equation as an exponent in the base that's in the problem. So this log 5x squared plus 8x plus 12 becomes the exponent for 5, and the 1 also becomes an exponent for 5. Remember the golden rule in algebra: what I do to one side, I must do to the other. We do this because this notation here, whenever we have the base here and the base here, allows it to just be the x squared plus 8x plus 12. 5 to the first power is, of course, 5. Now we can solve it algebraically. Subtract 5 from 12, we get x squared plus 8x plus 7 equals 0. Now we got a trinomial we can factor. It factors into x plus 7 times x plus 1 equals 0. If we solve x plus 7, we get x equals negative 7, and we get x equals negative 1. And I forgot to put my negative sign. Now, here's where you have to be careful, because what you have to do is you have to check these values. See, if I take negative 7 and plug it back into here, negative 7 plus 6 gives me negative 1. I can never have a negative value here. Also, if I put negative 7 here with the 2, I get negative 5. So I can't have a negative value in my value for a logarithm, so negative 7 is not a solution. If I take negative 1 and plug it in here, negative 1 plus 6 gives me a positive 5, I'm okay. Negative 1 plus 2 gives me a positive 1, I'm okay. Negative 1 is my solution. Alright, here's the second part to Chapter 6, Section 6. This is solving exponential equations. Now, I've got two examples here. Notice that neither equation, the 2 to the x power equals 5, and the 8 times the 3x to the 3 to the x power equals 5, you don't see log, you don't see natural log, you don't see anything. So it is an exponential equation, because in this type of problem we're going to do something different. We're not going to raise everything to an exponent. We're going to do something different. Like, for instance, this one here. As long as we have the base raised to a certain power by itself, we can go right into the mathematics that we need to solve it. So what we're going to do is we're going to, whatever this base is, we're going to take the log of that base on both sides. Remember, algebra, whatever you do to one side, you got to do to the other side. So we're going to go log 2, 2x, log 2, 5. The reason we do that is because, again, we have the base written twice, which leaves us just x. X equals log 2, 5. And if you remember from section 5, because it's in a different base than 10 or e, we got to do change of base. So we write log 5 over log 2, which is what x is equal. Now, on the problems that I give you for a test or whatever, you can either multiply it out and get an answer, I'm fine with that, or you can leave this alone. If we come over here, there's a little bit of a difference that we got to do here. Remember, we've got to get the base raised to a power by itself. So here we have an 8 attached. So the first thing we do is divide both sides by 8. Now we can do whatever the base is, which is 3. So we go log 3, 3x equals log 3, 5/8. This gives us x equals log 3, 5/8, which we do change a base. And we get x equals log 5/8 over log 3. This happens to be example 4. And I believe I had that wrong at the beginning. So this is still chapter 6, section 6, but this is example 4.